All right, we're on section 5.4 today, exponential and logarithmic equations. So we need to get our textbook open and our notes ready to go. And let's begin. All right, so if you're following along with me on page 390, we have two main ways to solve exponential and logarithmic equations. Rearranging the equations so that we can use the one-to-one property, or number two, rearranging them so we can use the inverse properties to solve them and come up with a rewritten problem that way. All right, so hopefully you become very comfortable with those properties that we were studying in the first half of the chapter. They will serve you well now. If you don't know them yet, it's not time to bail and give up, but it's time to dig in and ask some questions. All right, so again, this is just a review of those properties that we've been talking about. The top two there show us that one-to-one property. Okay, so if the large bases of your exponential equation match, x must be the same as y. Okay, if the log and the base of the log match, again, x and y for those logs would have to be a match as well. 3 and 4 work with our inverse property. Again, if you have these two numbers matching, the value of your equation is going to be that power, so you'd have a value of x there. And likewise on number 4, if this large part of your exponent matches the base of the exponent, your value for that one is going to be x2. So those should look very familiar. All right, we've already been working with rewriting and evaluating functions that have them. So let's take a look. All right, so checkpoint number 1. I'm doing problems that are at towards the bottom of page 390 right now. So if we have 2 to the x power, my guess is, okay, I ought to be able to do something to the 512 so that I have a 2 there as well. And if you investigate that and play with it a little bit, you are going to discover that 512 is the 9th power of 2. So now you can see your one-to-one property. Solving this equation, we get x equals 9. Okay, for b, with this one, I rewrote this one in exponential form. Okay, so right now in log form, that's a, obviously x, and this is your y. So if I rearrange that into the x equals a to the y form, I'm going to have x equals 6 to the third. All you need to do is simplify. X ends up being 216. 6 times 6 times 6. Letter C, we have 5 minus e to the x equals 0. Okay, so again, we have a variable x in this equation. So just like you guys would have done in the past, we're going to try to isolate that variable. So I'm going to move e to the x to the right-hand side so it becomes positive. And this time I'm going to kind of use that one-to-one property in reverse. So hopefully you can follow me through this here. If I do the ln of both sides, okay, we've done this where we've gone from this line and ended up to the top. So hopefully you can see the connection and see that I am doing it in reverse order. So I did the natural log of both sides. In doing so over here on the right then, okay, I know they don't write that little e there, but I think it's easier to see the property if I do. Those two match. So the right-hand side right now evaluates down to just the x. And then we have ln of 5 over here. Okay? You could go ahead and do ln of 5 into your calculator and come up with an actual rounded off number, but we'll just be satisfied with leaving it like this. All right, letter D. Let's play with this one. I'm seeing 9s and 3s, so I'm going to try to play around with 3s and use a one-to-one property if I can. So going after the 9 first, okay, everybody knows that is 3 to the second power. So I'm just going to rewrite the 9 as 3 to the second power, and then I still have that power of x as well. And just because the right-hand side's a fraction, I'm going to rewrite that as 3 to the negative 1, so it's up on top. Simplify the left side. If you have 3 squared raised to the x power, that's the same as 3x, or 3 to the 2x power. You multiply those two powers if you raise a power to a power, equals 3 to the negative 1. Now I've got that match. I've got the big 3's. So 2x must equal negative 1. Divide both sides by 2. I'm running out of room. And I solve my equation, x equals negative 1/2. Now I know this kind of thing looks perfectly simple when you watch somebody do it. That's not going to be enough. Make sure that you guys are digging into your book and doing a lot of these kind of problems in the early ones of your assignment pages. All right, checkpoint number 2, solve each equation and approximate the result to 3 decimal places. All right, so this first one here, we have the matching e's, so we can apply our 1-to-1 property right from the start here. The 2x here and the x squared minus 8 here should equal each other, so I can set up this equation. Now notice that you have a squared variable in here, you have a plane variable in here. Hopefully that triggers some memories from the past. I'm going to group all that stuff up, so I'm moving the 2x over. Generally, whenever you see a trinomial, what do we do to solve? Hopefully, you snap back into factoring. So we're going to have 2 solutions to this because there is an x squared in it. The first factor that we ended up with, x minus 4, gives us a solution of 4. And the second one gives us a solution of 2. Oops, no it won't because this is supposed to be a plus 2. Sorry. Good thing I caught that now. Okay, so x minus 4 and x plus 2 are the factors that you're going to have, which changes our answers to a 4 and a negative 2. All right, letter B. Let's go after that one. You have a 2 times a 5 to the x power. Now, you could go ahead, I suppose, and try something else on here, but since that 2 doesn't have a power, it's not like I can combine this and get 10x or 10 to the x power here. How then do I go about dealing with that 2? Well, hopefully you're thinking logically. I should be able to divide it away if it's multiplied to my exponent. So 5 to the x power is equal to 16. Okay, now once we're there, okay, we're going to do a little, I don't know, for me I can see the exponential form here, so I'm going to rewrite it in log form. Some of you are asking, why would you think of that? I don't know. You're going to do more and more of these kinds of things, but right now we're in x equals a to the y form. So the 16 is my x, this is my a, and even though it's an x sitting there, that's in the y spot. So when I rewrite this into the other form, I'm going to get x, which technically is in the y spot, is equal to log base 5 of 16. Okay. Now once I have it there, I do have a property that we learned about in either section 2 or 3, I can't recall, that gives us a way to evaluate that log base 5 of 16 using the change of base formula. Okay, do you guys remember log of 16 over log 5? Okay, now once we get it into that ratio, we're able to plunk those two numbers into our calculator. Okay, so log 16 divided by log 5, and we get 1.723. All right. So again, I would love to tell you why I try what I try. I try something, and if it works, great. If it doesn't work, I try something else. I'm one that likes using one-to-one property a lot or inverse properties a lot, and sometimes if you simply rewrite it from the form that it presents itself in to the other one, you're going to see one of those properties. Okay, this one didn't exactly do that, but I did get this log statement out of it, and then I could apply that change of base thing to it. All right, so when you're looking at an exponential equation like we did here, you know, rewriting it is one way to get that variable out of the power, and it put it out front. And then I was able to finish out my equation. All right, so I've thrown this caution out there before. Don't round off or approximate any values until the end answer. Okay, so when you see some of these log values, don't get calculator happy and start punching in log values and working with decimals because they've been chopped off. All right, so try to wait off till the end so that you don't have rounding errors. All right, so here's another equation. Again, you can see your x. We're going to need to deal with the fact that it's in a power. For right now, we can start isolating our x by moving the 7. Okay, so e to the x power is equal to 30. I've done one similar to this already. It was kind of like working backward with one of our inverse properties. Right now, if I did the ln of both sides, I would have over here a way to get x out of that power. Because the left-hand side now, using your inverse property, has a value of x. And then ln of 30, that's something that the calculator can handle. So I would end up with a value for my x. So again, I'm hoping that we can go through this for sure. We can have a big discussion about how I'm using that inverse property in reverse order here. It's about the best way to get that variable out of a power of a number. Okay, because if I did the ln to both sides, I'm going to get to use that inverse property and put an x out. All right, let's get a little bit bigger. Okay, so start picking it apart. Divide by 6. Okay, I do not want that t plus 5. That variable is in my power again. All right, so think about how maybe an inverse property could be applied here. With the big 2, if I did log little 2, which means I'd have to do same log to the other side. Do you see then how my 2's match here? So I can evaluate or simplify my left-hand side with my inverse property and get a t plus 5. Okay, now I can simplify and get the t alone. Subtract 5. So t is equal to that. Log base 2 of 7/6, that is something that you can enter into your calculator. When I did, and then I subtracted 5 from it, I did come up with a final answer of negative 4.778. So try loading that into your calculator. Go into that math key again. Go down to the log of different bases. I don't know, it was like arrowed down about 8 or 9 functions under that math menu. You can enter that in, subtract 5, hit enter, see if you get negative 4.778. Okay, now this one. This one's going to take a couple of looks. E to the 2x power. Okay, this is actually a quadratic. Okay, you guys know what quadratics are. Things that are in the form ax squared plus bx plus c that have that squared power. Well, think about what e to the x times e to the x would be. Okay, it would be e to the 2x. So that front term is a squared variable. All right, it is e to the 2x power. I can factor this thing. Okay, so try to follow me through here. Break the e to the 2x first. I just showed you that it was e to the x times e to the x. Then do the rest the same. I need factors of positive 12 that make negative 7 when I combine. So I'm looking at a negative 4 here and a negative 3 here. Okay, so now I take each of these individually, just like we did before, but we are working with e to the x right now. So take the factor, set it equal to 0. Move the 4. Now I need that x out of my power. Hopefully you're catching on to what I'm doing to get that done. I'm going to ln both sides. So again, if I write it in here for you to see, hopefully you're catching that that left-hand side now is my x. And I can punch ln of 4 into my calculator. And I get 1.386. Let's do the same thing to the other factor. So e to the x minus 3 equals 0. Move the 3. Then I can ln both sides again. ln of e to the x is x. And ln of 3, when you punch it into your calculator, 1.099. All right, ln of x is equal to 2/3. All right, so again, I'm going to play with this, and I'm going to try figuring out ways of where I could have come up with this thing. I have ln of x on this side, but I need to get the x out of there. So I'm going to write these. I know this is a little bit of a stretch. Follow me through. I'm going to make each of these a power of e. Okay? If this was here and we were working back up to this, okay, so if you were looking at this, I think you guys would see the one-to-one power and come up with that statement that's above it. So I'm working it backwards. I'm going, okay, so if that was something that maybe came from a one-to-one, what kind of statement would lead me there? Well, e to the ln of x equals e to the 2/3 would. Okay, now I can use my one inverse property on the left-hand side. If I have e to the ln of e to the e of x, that value is x. E to the 2/3, that can be punched into your calculator with your e button. Okay, so for right now, we're just going to leave it here. X equals e to the 2/3. The second one, okay, I really thought this was one of the easier ones that we've done for a little while, so it was curious that it was in this position. But you've got log base 2 on both sides. So this is kind of a straightforward one-to-one example that the book had. Okay, so again, it's under checkpoint number 6, but I don't know, I was kind of glad to see it because it seemed a little bit easier. So if I move x over, I get an x on this side. If I move the 3 to the right, I get a 7. Okay, so 1-to-1. This one here, with that subtraction in there, okay, I noticed that this was that quotient property. Okay, the logs matched. So with a subtraction in between the two pieces of the matching log, it's a quotient. So I'm going to condense. 4x would be on top. The 12 plus x would be the bottom. And now I still have the log 2 over there. All right, so now that after we condensed it, we have matching logs. So we can use our one-to-one property and say then that these two values must be the same. Okay, so multiplying both sides by 12 plus x gives me a 4x here and 2 times 12 plus x over here. So simplify. Move the 2x over. I've got 2x equals 24, or x equals 12. Okay. All right, so solve 7 plus 3 ln of x equals 5. So I'm at checkpoint number 7 now. Hopefully you guys go after that 7 first. Move the constant to the side with the other constant. Okay, I've got that 3 times ln of x on the one side. I don't want it there, so I'm going to divide both sides by 3. Do not punch -2 divided by 3 into your calculator. It's a repeating decimal, and you cannot do that. Now that I've got ln of x on that side, I'm going to again pretend this is something that I got from a one-to-one property, and I'm going to work in reverse. I'm going to e to the power both sides. Because remember with this little e here, if I have e to the ln of ex power, my value is x. Again, that's that one inverse property that we've been looking at. So x is equal to e to the -2/3. That again is something that your e button on your calculator could come up with. I didn't punch it in. So maybe I will do that here real quick. So to come up with that value for you, hang on. So we've got e key, and I want to go to the -2/3 power. And it's looking like this. Punch it in and see if you get the same thing. To 3 decimal places, 0.513. Checkpoint number 8. We've got 2 more to go. All right, so hopefully you guys are going to go after that 3 out front first. Okay, then if I, okay, this is tough, but there's a little 4 here. So if I, again, use the one-to-one kind of in reverse here, had this, do you see how I would have gotten to that statement that was on this line? Okay, I chose the 4 because then it would match my base of my exponent, and I'd get 6x as a value of the left-hand side. Okay, so I'm playing with those properties. I noticed the little 4 in my beginning statement, so that's why I chose the big 4 to put out front. Once these two 4s match, I can use my property and come up with the 6x. 4 to the third power, of course, is 64. Divide both sides by 6. X is equal to 32 over 3. Okay, we have one more problem. On example number 9 in your book. Okay, I did not want to retype this thing, so you're going to have to flip there with me. It was another one dealing with an exponential equation. Okay, actually it's number 10 in the book, I believe. Go to number 10, doubling an investment. Oh no. Oh, this is what I was doing with number 9. I'm sorry. Looking at number 9 in the book. Okay, there are sometimes extraneous solutions, so I just wanted to go through example number 9 with you. If you go through the thing, you're going to see how they solved it, and they came up with 2 answers, 5 and -4. Okay, so just look through that. They've got steps there and everything, but down towards the bottom, does everybody see x equals 5 and x equals -4 as solutions? Now, if you think about these and you put them back up into the original equation, the 5 works out just fine. But what if we put a -4 up into that first part of our equation, log 5x? We'd have log of a -20. Do you remember what happened when we tried playing around with our log buttons and pushed in a negative number? It came up with error. So it does tell us to be watchful when we have more than one solution, or when we come up with a solution, I suppose, in general, because sometimes they don't actually work. That's called that extraneous solution again. So be on the lookout. All right, now checkpoint number 10. You invest $500 at an annual interest rate of 5.25% compounded continuously. How long will it take your money to double? All right, so continuous, we've worked with this formula before. It is this one here. Here's where a few of you guys fell short. The investment itself, this is your principal. Okay, we have an interest rate here of 0.0525. It's continuous, so we don't have number of interest periods to worry about. And we don't have time. Okay, we're finding the how long. So that means we must have a value for A somewhere in this problem as well. We're looking for how long our money will how long it'll take for our money to double. So if we're putting in 500, the amount we're trying to reach would be 1,000. All right, so plug in your information to your problem. Oops, 525t. Divide both sides by 500. Okay, your variable is in a power, so get creative, do some of the things that we've been doing with our practice problems here. If I do the ln of both sides, okay, remember how if this little number matches the big number, the value of that side is this. And I have ln of 2 over here. Divide both sides by 0.0525. We're almost done. Now, ln of 2 can be punched in your calculator. Divide it by 0.0525. And roughly 13 years is what it's going to take us to double our money. And we're done. All right, I want you to turn in some problems this time. So beginning on page 397, take a look at 8, 12, 20, 38, 50, 52, and 60. Please have them ready to go. Come in before school if you need help working on any of them.